So this is 129S, and what is on the agenda for tonight is I'll finish the Chapter 3, and then I'll demonstrate ED103 SQL injection, which is the same thing people saw in my 127 class if you're in that. And then I'll just demonstrate the first W project, W600, which is getting your Web Security Academy set up. And from then on, the rest of the course you'll just be doing Web Security Academy projects. So, let me get my slides, which will be here. All right. Here. There we go, Chapter 3. Okay. So we went to the second Kahoot last time and pick up here. All right, so. Get my window set up. All right. So there's server side. When you look at a web page, there's some part of it is being done in your browser on your machine, and some of the work to create that page is being done on servers. Now, in the old days, Web 1.0, you would just have static web pages, like mine, for example. It's just an HTML file and a few images just sitting on a server, and it's really nothing more than a file share. You connect with your browser, you download the file, you see the file. That's Web 1.0. But nowadays, with dynamic content, where you log in and everything you see is customized like Amazon, then there's a bunch of scripts, in fact, on a whole bunch of servers, going to databases, picking up the ads for you and the specials for you and your previous purchases and all that jazz. So your browser is setting up parameters, like a cookie that identifies who you are, and all those scripts on the server are calculating the customized content to show you. So when you send parameters up to the server, there's various ways to do it. One way is in the query string, writing the URL, like here. Let me bring this down. Here's the URL to see my page. And you could put a question mark here, and then say A equals 1, and B equals 2, and so on. And I think I can actually zoom in on that, and it'll look okay. Yeah. All right, let me try zooming in on it. So, this is called the query string, where you just put parameters right there in the URL. That's one way to send data up to the server. It is the least private way to do it, because that data will end up in server logs and in bookmarks and such. So you shouldn't be sending passwords or anything there, but people often send information there that's used for advertising purposes. When I post news links on Twitter from certain news sources, I'll see a whole bunch of those things there which specify the ads that are going to show on the page, and I trim them off before posting it. Anyway, then you can put it in the path, so it looks like just a file, a folder name. That's REST type URLs. You can put data in cookies, or you can put it in the body request. If you use the post method, then you just have as many parameters as you want after the HTTP request. And this is where you should put it if you're logging in, sending sensitive data, like passwords. By the way, everything in the HTTP request can be used. Now let me just get burp up, because we're going to be using burp forever. And it's the best way to get a nice demonstration of this. So I've started burp. And let me just demonstrate the process, because you're going to have to get used to it. When you start burp, it's got an update. I'm not going to update right now, but I could. Then it's going to ask this project stuff, but for the free version, you don't have the option of this stuff anyway. So I just click Next. Then I start burp. Burp always starts in a useless condition, which is one irritation about burp. So when burp starts, it doesn't allow any traffic to go to the internet. So what you have to do is go to proxy and turn off intercept. So instead of blocking every request, it lets it go through. Then you can open the browser and now just surf the web in this browser that will pop up. And there we are. Here's my browser. So I can just type in any place I want to go here. Like if I want to go to my website, here, there it is. All right, and if I want to open the page for this class, that's here. But let's take a look. Right now, opening my web page, if you go to HTTP history, had a lot of requests because of Twitter links on my page and such. So I'm going to clear all this old stuff with right-click, clear history. Yes. Yes. All right. Now I'm going to click the link for this page, 129S. And there we go. Here's the original get that loaded that page. Then there's a bunch of junk about the YouTube videos on the page, which are all full of links to ads or something. I'm not sure what all that junk is. But here's the original get that loaded the page. Here. And if you select it from the list, you can then see the request and response here. So this is the get that loaded the page for this class. So you have a get, the number of page, so this sent a host, then it sent some cookies, and some more header features here, user agent, and more header. You can have as many header lines as you like, and so your server gets all this information. Now you might look just for parameters like the cookie, or you might look for any of these parameters here and use them. All this data is in principle available for your server app to use. You can program it to do anything you want. So, like I say, you might use the user agent is commonly used. You might have a version of the page that's designed specifically to fit on small cell phones. So when you get the user agent that looks like a cell phone, you'll switch to that. And a lot of people show different pages to the Google search engine than they show to real users. And so if you change your user agent to be equal to the Google search engine, you'll often see more content on a site. So on the server, there are scripts in PHP or Perl or Vbscript, or Node.js is a common one too, or ASP, web application platforms like ASP or Java, and servers, which are what listens on a port and takes the requests like Apache and IIS, and databases holding all the big piles of information like all the customers, all the purchases, all the ads, all the business partners are all stored in databases, and lots of other file systems. So you're usually talking to a whole bunch of different servers all working together to construct the page you see. Java is what enterprise class applications usually use. If you want to make money, I think Java is the most highly paid language to learn. It is really hard to program in Java, but they will pay for it because it scales to big server clusters. And it runs on every operating system, equally badly on every operating system. But anyway, that's why pros learn how to write the code well, because you will need it. I just wondered if I can do anything about this. Oh, I see this. This might help. All right. Trying to improve my amateur theater. Anyway. All right, so Enterprise Java Bean is a component Java uses. Plain old Java Objects is another one. And Java Servlets. These are various components you use in Java-based application. Yeah, well, I'm glad you like Java. I like Python. I don't really like Java that much, but anyway, you can get they're both very valuable to learn. You can get real jobs programming them. And so then there's Java Web Containers. They provide a runtime environment for this, and you'll see Tomcat, WebLogic, and JBoss are Java-based web servers. So there are third-party components too that are used for authentication, the presentation layer, databases, and logging. Log4j is here, which is kind of funny. There's I don't think Java is more secure. I wouldn't say that. Java is the most secure, especially now. We just had a huge disaster with this Log4j module. So I think none of them are necessarily secure. All these languages have similar bunch of bugs that come and go. You really have to stay on top of it and patch things and just read the news. You know, there's always something. Maybe people thought Java was more secure, but then it had a huge disaster. I think nothing is that secure. It's all in the skill of the person using it. But as Log4j has been found recently to have a serious security vulnerability, and that exposed a whole bunch of websites to an attack, they thought they were secure. Just like people that ran open source web servers thought they were secure, and then Heartbleed came out and exposed that they'd all had a huge hole for years without knowing it. Log4j just did the same thing. Java does not reuse the stack, uses new stack for every function. Yeah, that's good. Java does have some good security features, But it's got holes and bugs too. They all do. ASP is Microsoft's competitor to Java, and it runs on their .NET framework, which is Microsoft's very popular language. And if you're taking 127, we're going to reverse engineer. .NET runtimes are very easy to reverse engineer, and by the way, so is Java. Java and .NET both do not compile down to assembly code or machine code. They compile down to bytecode, which is then run in a virtual machine, either a .NET runtime or a Java virtual machine. And that is very close to source code. Those apps are distributed with code that is essentially the complete source code. And a lot of developers don't understand that. Anyway, that's the .NET framework. And you can write your application in C# or Visual Basic or other languages, and it will be digested down to this intermediate language. Microsoft calls it, Java calls it bytecode, which is a hardware-independent kind of assembly language. Anyway, Visual Studio is Microsoft's coding platform. All the people that work on Windows pretty much use it. It's a huge product. ASP, yes, I think ASP is still commonly used. Yeah. Yep, that's right. Log4j was like the old OpenSSL vulnerability. Absolutely. All right, so ASP.NET is used in Visual Studio. Is considered quite easy to use for Windows developers. They like it a lot. And it does prevent some vulnerabilities. It's built into the language and the platform. PHP is the one I've used. This is what open source people tend to use. It's considered kind of amateurish and unprofessional, does not scale to large server clusters, and tends to have serious security vulnerabilities, but it's easy to write active content for web pages. So it typically goes on a LAMP server. Linux, Apache, MySQL, and PHP typically go together, and that's the LAMP, L-A-M-P. And that's what you do for simple websites like mine, where you just want to make one simple web page. But it's very easy to make mistakes and have vulnerabilities in PHP, and it's used all over the place. Very popular in open source applications, and WordPress is based on PHP, which is probably why it keeps having so many serious security vulnerabilities. People write extensions. The WordPress main engine is pretty cleaned up and secure now, but people contribute extensions like amateurs. And so there's always an endless flood of extensions that are popular that turn out to have some serious security vulnerability. Yeah, Drupal is also PHP based. I didn't know that, but Drupal has some serious vulnerabilities too. As you saw in the project last week, I had a vulnerable Drupal server up. So anyway, there's many, many PHP based products for webmail and bulletin boards and shopping carts and everything. Yeah. Well, I know WordPress is PHP, so yep, if Drupal does too, that probably explains why both of them have so many security problems. Ruby on Rails is another product that was really quite popular. I haven't heard much about it in the last few years, but it's another way to generate websites. And SQL, which is what we're going to do in the project in demonstration later. This is how you have a database. If you have a bunch of data to store and you use a proper database like SQL, then you have structured tables and you can search for things, search for customers by name or ID or address and things like that. If you have a large amount of data, you really need a real database product. You can't use something simple like a spreadsheet. And that's what you have here. So you use SQL queries to update, add, read, or delete data. Good. See a lot of good comments going by, which is good. All right, so XML is just a way to record data so it's machine readable. So if you wanted to record pets, it's HTML is a subset of XML. So you have this thing called a pet. So you start with a pet tag, you put in the name, you end with the pet /pet. Everything has an opening and a closing tag. So this is Ginger, and there's a group called pets. There is a dog called Spot and a cat called Paws, and that's the end of the pets container. So this is just a way to organize information. Any kind of information can go in here. Microsoft Office used to use a proprietary binary format to store Word documents, and around 2008 they switched to storing everything in XML, just because it's machine readable, it's easy, it's the standard. Any kind of data pretty much can be stored in this format, and it's usually the best way to do it because it's very simple and easy to automate scanners to read through it and so on. So another thing is you can use HTTP and XML to exchange data. you can have a server handing out some data and use SOAP, Simple Object Access Protocol. So this is a server storing some quotations, so you can post a quotation, and then this is the quotation in XML. So you've got an envelope, a body, there's the quotation's name is Microsoft, and so on. So this is just any kind of data could be sent to a server, and this is often what happens if you open an app on your phone and you update something, like a contact's phone number. It's often sending a request like this off to a server to update that phone number. And so COAP response will look the same, 200 OK, because it's based on HTTP, and down here is the response, showing here's the quotation. So you send up a request for the quotation by quotation name, and then you got the quotation. So if you have user-supplied data, it can have code injection vulnerabilities. For example, here, I put a quotation name, and I typed in this name, Microsoft, for example. So if I'm allowed to put less than and greater than signs in this, I could actually put in this closing XML and open another XML tag and insert extra information here, and that's the sort of attack we're going to be doing for the whole semester, where if you can control any part of a request, there's very often a way to maliciously alter that request to create an effect that the developer did not intend. That's the essence of all the hacks we're going to be doing. All right, and so servers running SOAP typically use WSDL to publish what services are available, and there are tools that can read that and then customize responses for you based on it. So let's try a Kahoot. Okay. Fit my Kahoot on the screen and go here and here. And it's 3C. I think I'll leave it here so my head doesn't cover the active ingredients. There. Looks pretty good. All right. All right. Give it a few more seconds and see if there's any more people coming. I guess that's it. All right, what system uses POJOs? Plain old Java objects, so that's Java. All right, what language is used on LAMP servers? PHP. That's what the P is. All right. So what system looks like that with those angle brackets? That's XML. All right. Extensible markup language. And what system uses WSDL? There was a typo in the question? Well, I didn't see it, but there could easily be. The person who writes these questions is kind of sloppy, you might have noticed. All right. That SOAP servers use that, Web Service Description Language. All right. I think that's Judy. And that's a name, I know. And I know who that is. All right. All right, let's go back to the slides. Okay, so in the browser, your browser is doing some of the work, and the first thing your browser does is it takes the HTML, which builds a web page, and it builds the visible web page out of that. HTML or XHTML are very similar versions of the same thing. And so the HTML has a lot of code in there, like hyperlinks. Ahref gives you a link. It'll make this stuff blue and underlined, and when you click on it, it'll make a web request, which will start like this, and then have more lines with cookies and such. You can have HTML forms like this, where you specify the action, which is what script you run on the server. And as you see, I was using a PHP script. It sends the data with get, which means the data you put here will be put in the URL. So this is a poor practice to do what I did here. It's going to take a name and password, and it's going to put it as a query string in a GET request. It would be more secure to use POST. And then it will just take the name and input, and this submit button down here will submit. So this is the HTML form that takes data and sends it to a script on the server in a scripting language. So then you can, when you click go, it's going to send you this. It's going to send a GET request to the PHP script on the server, and it's going to put the username and password right here, where it really shouldn't be. It'll work, but it's not the most secure way to send it. And there it goes with other information here. All right. Now you can also send it with method equals post and encoding type multi-part form data. This is another option, and this will do something really strange, which I don't understand why this happens, but it puts it down here where post data would put, and it creates this random string of letters here as a tag, and it puts that in here to break up the pieces of data. So the first name is here, the last name is there. I don't really know what the point of this is, but that's how it, that's what this multi-part form data system is. How is post better than get? Well, post is better than get because when you send it with post, the parameters are just right here. And the point is they are not in the URL, so they will not appear in server logs. And if you save a favorite in your browser, they won't appear in there. That's all. That's the only reason post is better than get. It avoids storing your password in foolish places. Now, they both, of course, if you are not using HTTPS, then all this stuff is sent without encryption over the internet, and it's not safe. But if you are using HTTPS, then it's all encrypted. All right. So cascading style sheets are used to decorate your page, change colors, sizes of fonts, and so on. So you can take your header tags and turn them red. And JavaScript is scripts that run in the browser. So you can put a script on your page, and it will run in the browser of the person viewing it if the browser allows it. But you don't know whether they've turned off JavaScript. Now, almost everybody has JavaScript turned on now because most pages require it. But as a developer, you need to be aware that you cannot trust anything that runs in the client's browser. They could alter it, turn it off. You can't assume that that code runs the way you wrote it. This is actually a big deal these days with Wordle. You know, there's this game people play where you get a word to guess once a day, and New York Times bought it, and they're people afraid they're going to put it behind a paywall. You could just save Wordle on your machine and run it locally. It's a JavaScript game running entirely in your browser. You have all the code right there. It's not really using a server for anything. Same thing's true of some binary games I wrote, which I think Irvin's using this semester. Yeah, Wordle's pretty easy to write, pretty easy to cheat, yeah. Oh, I see a link here, a message. Oh, JC is not who I thought it was. Oh, good, thanks for telling me. Let me make a note of this. Okay, good. Yes, people have made several Wordle clones. It's not really that hard, especially since you could start from their code and modify it. Yeah, Wordle is not a complicated game, but it's a fun one. Anyway, so JavaScript are things you do in a page, and if you want to change objects on a page, you use the document object model. Yeah, good. People have ways to, techniques for Wordle and stuff. Anyway, Vbscript was Microsoft's attempt to write a scripting engine to compete with JavaScript, and it was pretty much a failure. It was only supported in Internet Explorer. It's pretty much considered obsolete and fading out now, although some people still continue to write VB scripts for specific purposes on Windows machines. So here's the document object model. You have a document, which is the web page you're looking at. Then you have the HTML root element. Then you have a body, and the body will have like an ahref and a header and so on. You can refer to any part of the page by this model. And so, for example, if I want a page and put the word hello world down here, instead of putting it there literally, I can insert it with JavaScript. So down here, I have a PID tag. So I make a paragraph and a slash paragraph, and I give it an ID of demo, and there's no text in there. But this JavaScript can put the contents in there. So it's document, get element by ID demo. So we'll look in the document for something named demo, and then I can change the inner HTML, which is the stuff between these tags, to be hello world. So the point is, instead of just having static text there, I could have calculated text that I fill in depending on circumstances. This is how you make a dynamic page that calculates the elements on it, but this calculation is being done, in this case, by the user's browser. So if the user turns off JavaScript, they won't see this text. And so Ajax is a technique that came out a few years ago, and the point here was, it used to be that if you wanted to update any part of the page, the only way to do it was to reload the whole page. But Ajax, with asynchronous JavaScript and XML, you can fetch a small amount of data, and now you can have things like Google Maps. You can look at a map, you can grab it and drag it down, and instead of reloading the whole page, it loads just a little bit of the part here to fill it in. And you'll see a lot of requests go by with these long lists of parameters in Wireshark. You'll see them go by as it loads a little bit more and a little bit more, so it can just fill in that page as you drag it. That's Ajax. And this is very useful to get a small amount of data at a time. Then the JSON is another way to lay out data. We saw XML before. This is another way to do the same thing. Instead of using opening and closing tags, you use curly braces and then name:value. So a parameter named name is called Mike Kemp, and ID is called that, and so on. You could very easily do the same thing in XML. It's just another way to do it. So you can send an update to the server, or a post request to the server, and someone's asking me, here's a post request. You have a blank line, and then you just put the data down here. And the data is all in one JSON object called contact, and that has the new name, the ID number, the email, and then submit equals update is put down here, so it knows I want you to update it. One thing, by the way, about this request is that there's no authentication. This is looks like a page with insecure direct object access vulnerability to me. I can send a post and change something in the database, and nowhere did I have a password or a cookie or anything, so it looks to me like this is insecure. Anybody that finds this, can use it to alter the data in the database, and that also happens all the time. We're going to do a lot of that as you go ahead, where people have objects on their website that you can get to without passing through authentication first. Now, your browser tries to separate the content in different domains. So if you have a cookie from yahoo.com, it will not send that cookie to amazon.com, but only to yahoo.com. And you have a whole database on your machine of all these cookies, and that's the point. The problem is it is pretty easy to trick your browser into getting confused about what page it's really on, and then it will send the data to the wrong place. So there are a lot of attacks we'll go through. Cross-site scripting, cross-site request forgery, and other attacks are based on tricking your browser into doing something on the wrong site. That's the cross-site part. So it does something that should have only been done on Yahoo. In fact, it does that on some other page that is just pretending to be Yahoo. So a page on one domain can cause an arbitrary request to another domain, but it can't process the data returned from that. This is the same origin policy. So your page can have a form that sends the data somewhere, but it's not allowed to read the data coming back from it. It can load a script from another domain. It can't read or modify the cookies of any other domain. That's the goal of the same origin policy. HTML5 is the newest version of HTML, came out maybe 5-6 years ago. And it has, the main thing about HTML5 is it makes it possible to play things like videos natively on the page. You do not need as many browser plugins. You used to need things like Flash. Flash is, I think, completely extinct now. And you can just do a lot more with native HTML5. Right, and it added this XML HTTP request for Ajax to make it even better to send small amounts of data back and forth. And it had a client-side database issue, which people worried about. And we'll talk more about it as we go ahead, although I'm not aware of any actual real-world consequences that have come up of that. So Web 2.0 is the modern web we're using, where you have these interactive pages where you log in and you see custom content. Some people call Web 3.0 the new blockchain thing with NFTs, but that's really new and emerging, and it's not covered at all in your textbook or really in this course. That's just in like an early alpha or beta stage right now. But Web 2.0 is what we're all using. And there are some of these browser extensions. 10 years ago, everybody had to have Java and Flash and ActiveX in their browsers, these sort of things to run scripts. Now, less of that is needed. These browser extensions caused a lot of security problems. Client-side Java was a wide open door for about 10 years. You could just take over machines through it. There were tons of Flash attacks. Silverlight was Microsoft's competitor to Flash, and it's been extinct for years. All these are pretty much extinct as client-side extensions. Very few people use them anymore. All right, and so you have stateful data to upgrade HTTP to be stateful. HTTP itself just has one request, one response, and that's it, no memory. So all these cookies are put in there to add that on later, which is not really part of the HTTP protocol. It's added on at a higher level. So you have a server-side structure called a session, which is some kind of record of which cookies are associated with people who have logged in and who haven't logged out or timed out yet. And then that contains data, like items added to a shopping cart, and you can store state data on the server or on the client. So some pages, when you add something to your shopping cart, they do not tell the server at all. They just put it in a cookie on your machine. They don't tell the server anything until you make a purchase. Other people store it all on the server. You can write your page either way. So here, the tokens generated by a second-factor authentication and stored in a local computer are pretty dangerous. Well, that is an issue. There is a new attack that just came out in the news today of something that will steal the connect to your cryptocurrency wallet that's implemented as a browser extension, and it will, I think, also steal stored passwords. So, yes, things in your password manager as a browser extension are subject to attacks through the browser. And in particular, the default built-in password storage feature in things like Edge and Firefox are frequently attacked. So as a security recommendation, it is generally better to add a separate extension and don't use the built-in one. Of course, there are patches, but that's why I say anything in the browser is clearly going to get attacked a lot. Every page you load has some possibility to connect to it, but they do try to secure it. So I'm using, I think, LastPass. Is that what I got here? Yep, LastPass. And LastPass did get hacked about 5 years ago. They got some data, but they patched it. So, I mean, you make your own decisions how you want to do it. I highly recommend using a password manager of some kind, because if you don't, you're probably going to reuse passwords, and that's the worst thing you can do. Thoughts on the security of JSON web tokens? Well, as far as I know, the fact that they're JSON has no security consequence at all. I mean, that's just a way of storing the data. Although there may be more what you're asking. You may know something more than I do about them. But the fact that they're JSON, I don't think matters. The question is how they're transmitted and where they're stored. One good thing about a password manager, though, is there's a master password. The problem for Firefox, for example, is if you store passwords in Firefox, it will not prompt you by default to put a master password on the browser. So those are just wide open to anybody that uses your machine or anybody that hacks into your browser. You can optionally add a master password to it, but if you don't, they're just sitting right there. These third-party extensions like LastPass force you to use a master password, and that's better. Anyway, so when you have data, you got to encode it somehow, because all the computer knows is binary. Everything has to be turned into numbers. So if you have the URL, like the URL up here, https://samsclass.info, you can only have printable characters up here. You can't have binary characters, but you can add them by using, these are the printable characters from 20 hexadecimal to 7E. And if you want to send other kinds of characters, they must be URL encoded. I should have an O there. All right. So this is URL encoding. Use a percent and then 2 characters of hexadecimal. So 3D is equal, 25 is percent, 20 is a space, 0A is a new line, and this is a null byte. So you can put URL encoded binary in there. All right, and here's somebody with LastPass phishing. Yeah, they're good. Got a LastPass attack. There are various ones. All right. Then there's Unicode encoding system. If you want to send up Chinese or Arabic or any non-English language, then you need more than 1 byte per character. So you use this %U and then more than 1 byte worth of hexadecimal, like up to 4 bytes. All right. Yeah, good. So here you can get these non-English characters. UTF-8 is the modern variable. I see this is Unicode 16-bit character. It looks like Microsoft 16-bit Unicode. Here's the modern system, UTF-8, which is variable length. So you can put a percent around each byte. So this is 2 bytes for a copyright sign, and here's 3 bytes for a not equal sign. And there's a ton of these things. Yeah. All right. By the way, I see a comment there, which is a really good point. If you want better two-factor authentication than using a browser extension, you could use a YubiKey. That is considered quite good, a hardware USB device. Or I think it might be able to connect with Bluetooth too. That's a separate piece of hardware, is more secure than a browser extension. It has a smaller attack surface in general. Although I'm sure it has its flaws too. Everything does. So HTML encoding is how you encode special characters to be viewed in a browser on a web page. So if you don't want a quote to have its special meaning, which is usually pretty harmless, but anyway, you can use ampersand, QUOT, semicolon, here's apostrophe, ampersand, less than and greater than. These ones are quite useful. If you HTML encode these characters, then you will prevent cross-site scripting, because if somebody tries to enter data in like a name with a less than and greater than sign, you encode them so that when they're displayed to the next user, they do not have the effect of being meta characters that create tags. U2F, then O, then QTP. An OTP? Well, I'm not sure. Not sure what you mean there, but anyway. All right, so one-time password, and I'm not sure what U2F is. Anyway, so you can, any character can be HTML encoded this way with a pound, and then you have hexadecimal numbers. So you can express anything this way. These characters that normally have special meaning in HTML, which is why you got to encode them. That's exactly right. Yes, Otherwise, if you were to like put a less than sign in your name and print it, your browser would interpret that as the beginning of a tag, like a bold tag or a header tag, and it would follow up the page. And that's what cross-site scripting does. So if you do want to have a less than sign in something you're posting, like for example, if you want to post a post on Facebook or something describing how to write code, and you want to put code samples in it, you have to encode them like this. Like my projects say, type in this code. I have to encode the special characters here to make sure they will render correctly. Yeah. All right. And then there's Base64 encoding. If you want to send an image by email, or if you want to put it in a URL or a parameter of a website request, you can't use all the binary characters. So what you do is you Base64 encode it. You take 64 characters that are printed, which is uppercase letters, lowercase letters, numbers, and then 2 more characters, typically plus and slash. So now you have an alphabet of 64 characters that are printable, and you take the binary, which is 8 bits at a time, and you encode it with 6 bits at a time. So every 3 letters of input, 3 characters of input turn into 4 characters of Base64. And now you get a blob of these characters, which can encode any kind of binary data. It's not encryption. You can decode it with websites or Python or anything, but it's just a way to encode 8-bit code 6 bits at a time so you can transfer it over a text-only medium like email, or for that matter, a URL. And then there's hexadecimal encoding, where if you want to send ABC, instead you just send the hex codes in ASCII. So 41 means 4 16s plus 1, 65, that stands for A, and so on. So this is really encoding it 4 bits at a time. So it takes 2 characters to encode every 1 character. Yeah, these are used all the time. Anytime you want to send a binary over any kind of medium, like you either express a binary as hex encoding, or you express it as Base64 encoding. Yeah, uploading a photo to be stored in a database, trying to download a binary object through a text-only medium. Email. Email is where it all started. This was originally here to add images to email. In the early days, email was text-only. And then people wanted to send pictures, and so you would run it through an encoding program to encode your picture as this Base64, email it to people, and they would run a decoder on the other end, and now your email clients do that automatically. But email never supported anything except printable characters, and it still doesn't. All the binary files attached to your email are in fact being encoded as Base64. All right. And there are serialization frameworks. The main one still used is Java. I think Silverlight is gone, and I never have used Flex, so I'm not think that's around either. But you can, if you have a lot of parameters, like a username, a password, a cookie, like say 10 parameters you want to send to the server, in Java, and for that matter, also ASP, you can choose to make one blob of data. And that's called a serialized object. You take all this information and you make one object like a binary file, and then send it to the server. And this original idea was then you could trust it. You could store that blob of data on the client, and when it came back, you could believe it hadn't been modified. But the problem is the early versions of these serialization systems did not have any encryption or signatures or hash values or anything. So in fact, you could open it and modify it. And there were a whole bunch of deserialization attacks where you would open that and modify it. So there are modern versions of these serialization objects that append a digital signature to it so it can't be modified. But if you're using the older versions of them, then this tends to fool the developer into thinking they can trust the data coming from the client when they can't really. And there are burp extensions to deserialize serialized objects. The textbook, oh yeah, someone's got the Humble Bundle book. That's a good thing. Yep, there's serialization in PHP. There's serialization in Python called Pickle, which is kind of crazy. Yep. Yep, lots of books. Good, yeah. Okay, so let's take a look at the last Kahoot, which is somewhere around here. There it is. Okay. 129S3D. Yeah, I think I learned about pickle from a CTF. I've never used it in real life. But the Java serialized objects, those are really used a lot. That's the main kind of serialization attack I see. All right, I guess that's it. So, what system defines formats like that? Yep, that is cascading style sheets. That's what that stuff is. All right, which one of these is obsolete? Vbscript is effectively obsolete, although I must say one of my clients hiring me to develop a course for a corporate client, they demanded a lesson in how to use Vbscript to do forensic acquisition, and I figured out how to do it. They said, you have to write this chapter. I said, that doesn't seem like a good chapter. And they said, tough, the types of chapter have already been chosen. So I wrote projects in Vbscript. I don't recommend it, but it is still included in Microsoft Windows, although not in the browser. You can write VBS scripts. They really look horrible. Anyway, it is still present in Microsoft Windows, and you could use it, but I think it's really on the way out. Anyway. All right, what system requests data from the server without refreshing the whole page? Yep, that's Ajax. Asynchronous JavaScript and XML, used for Google Maps and things like that. So, what system turns a space into something like that? That's actually a non-breaking space. That's what it stands for. I use it all the time. That's HTML encoding. All right. All right, I know who that is. All right, that's a new one for tonight. And another new one, good.